So in this video, I'll discuss the nature and properties of gases. So this is a dedicated discussion on gases. So continuation lang siya ng aking discussion on the different states of matter as a consequence of their IMFA. So in gases, the molecules are not constrained by their intermolecular forces of attraction. So different siya from the liquid and the solid states which are constrained by IMFA. So sa gases, ang kanilang movement ay free and random due to their kinetic energy. So the properties of the gases can be explained by the kinetic molecular theory. So ano yung kinetic molecular theory? This is a model that describes the movement and the properties of gases as a result of this particular phenomena wherein yung kinetic energy nila ay far greater than their IMFA. So ano nangyayari dun sa system? Okay? So here are some assumptions of the kinetic molecular theory. So for the first one, we are assuming that the molecules are in constant, random, but linear motion. So yung mga linear motion kasi, pwede silang hindi nag-accelerate. So constant lang yung movement nila, wala tayong increase or decrease in the velocity. Okay? So unlike the circular motion na acceleration, yung mga linear motions, okay, they are steady motions. Okay? Wala silang net acceleration or deceleration. So mas magandang i-describe natin yung gases through that particular model or through that particular assumption. Okay? So here are some ideal gas assumptions naman. So kapag ka ideal gas, you are describing your gas particles through assumptions 2 and 3. So sa assumption 2, the IMFA between the gas particles are negligible compared to their individual kinetic energies. So yung interactions between the particles, negligible siya kung i-compare mo dun sa energy of motion ng ating mga particles. So the volume of the gas particles are also negligible compared to the distance between them. So sobrang liit ng mga gas particles natin kung i-compare mo dun sa distances between any two gas particles dun sa system. So ibig sabihin yung volume occupied by the gas in the system is far greater than the sum of their individual molecular sizes. Okay? So parang point particles na lang yung ating mga gas. So negligible yung kanilang size or volume. Okay? So these are the ideal gas assumption. So kapag sumusunod sa ganitong model yung iyong gas, you can call your gas an ideal or perfect gas. Okay? So for the rest of the assumptions, we have number 4, the temperature of the gas is directly proportional to the average kinetic energy. So kapag nag-i-increase yung temperature, nag-i-increase din yung kanyang kinetic energy. Okay? So the pressure of the gas is also described as the total average force exerted by the particles per unit area of the container's walls. So yung ating pressure kasi ay force per unit area. So kapag meron kang designated area, kung gaano karami yung particles na nagko-collide doon sa area na yon at kung ano yung force of collision ng mga particles sa area na yon, that would be the pressure of your gas. Okay? So for number 6, both the particle-to-particle and particle-to-wall collisions are perfectly elastic. So ang ibig sabihin ng perfectly elastic collision, yung kinetic energy niya ay nape-preserve kahit pagkatapos ng collision. Okay? So hindi nababawasan yung velocities ng ating mga particles as they move past that collision. Okay? So no loss or gain in the magnitude of the kinetic energy after the collision of the particles. Okay? So the kinetic molecular theory can also describe the distribution of molecular speeds. So nalalaman natin dito kung gaano karaming particle yung may mga specific speeds. Okay? So at a certain range of speeds, malalaman natin yung population ng particles na napopossess ng mga speed values na yun. Okay? So hindi pare-pareho yung speeds ng mga particles sa ating system. Meron tayong mga particles na mababa ang speed or mababagal, meron din tayong mga particles na mabibilis. So namamap yun ng ating Maxwell-Boltzmann speed distribution function. So this distribution function is derived from the assumptions of the kinetic molecular theory. Okay? So kapag constant yung mass at mababa yung temperature, makikita natin dito na concentrated sa iisang value or sa isang range of values yung mga speeds ng particles. So ibig sabihin, mas similar yung mga speeds ng mga particles nila. Okay? Kapag mas mataas naman yung temperature, mas varied yung speeds ng ating particle, although mas mataas yung average speed ng ating mga particles. Okay? Mas mababa yung average speed kapag mas mababa yung temperature. So this makes sense kasi mas mabagal dapat ang particles kapag mababa ang temperature kasi mababa ang kanilang kinetic energy. So kapag constant naman yung temperature, kapag matataas yung particle mass, hindi masyadong varied yung kanilang speeds. Halos pare-pareho sila ng speeds or concentrated sa kakaunting range yung kanilang speeds. Okay? Mas nagva-vary yung kanilang speed kapag mababa yung mass. Okay? So, nagkakaroon ng particle na sobrang bilis, nagkakaroon ng particle na sobrang bagal kapag mas magagaan yung particles nyo. So, ibig sabihin, mas kalat yung range ng speeds kapag mas magagaan yung particles. Okay? So, the kinetic energy, as we know, is 1/2 mv squared. So, ito lang yung mga factors na pwede nating i-vary as for the distribution of the molecular speeds. Okay? So yung Maxwell-Boltzmann speed distribution function can be dependent to both mass and the velocity of each of the particles in the system. Okay? So, tandaan lang natin na kapag mataas ang temperature, mas mataas ang kinetic energy, and therefore, mas madami tayong collisions. Okay? So here we have the gas laws. Okay, meron tayong mga types ng mga gas laws. So kapag kino-consider natin yung change in parameter, gagamit tayo ng mga empirical gas laws like the Boyle's law, Charles law, Gay-Lussac's law, and Avogadro's law. So yung combined gas laws, combination lang siya nitong apat na empirical gas laws na ito. Kung kailangan lang nating i-describe yung state ng isang gas, so kung kailangan nating malaman yung volume given the pressure, number of moles, or temperature, gagamitin natin yung tinatawag na equation of state. Okay? So an equation of state is the description or the complete description of the parameters of a certain gas. So hindi tayo nagko-consider dito ng change. Dinedescribe lang natin yung current state ng gas. Kapag gusto nating mag-predict ng changes, gagamit tayo ng mga empirical gas laws. Okay? So yung combined gas laws kapag more than one parameter yung nag-change at a time. So for the Boyle's law, mag-work lang yung law na ito kapag constant yung temperature and number of moles. So P1V1 is equal to P2V2. So yung pressure at volume dito ay inversely proportional. So kapag nag-i-increase ang pressure, dapat nagde-decrease ang volume. That works again at constant temperature and number of moles. So yung Charles law naman, at constant pressure and number of moles, okay, T1 over V1 is equal to T2 over V2. So kapag nag-i-increase ang temperature, nag-i-increase din ang volume at the same degree. Okay? Yung Gay-Lussac's law, at constant volume and number of moles, P1 over P1 is equal to P2 over P2. So kapag nag-i-increase yung temperature, nag-i-increase din yung pressure at the same degree. So yan ay mag-work lang kapag constant ang volume and number of moles. So yung Avogadro's law, at constant pressure and temperature, N1 over V1 is equal to N2 over V2. So kapag nag-i-increase yung number of moles ng inyong particles or number of particles dun sa system, nag-i-increase din yung volume niya. It only works at constant pressure and temperature. Okay? So for the units, okay, for the number of moles, we use moles. For the temperature, we use Kelvin. Okay. For the pressure, we use APM or atmospheres. And for the volume, we use the liters. So makikita nyo sa literature yung mga conversion factors niyan. Kung iba yung unit na binigay, mas maganda na i-convert nyo na siya sa mga standard units na to before using the empirical gas laws and also this ideal gas equation. Kasi yung R dito, yung gas constant, especially dito sa equation na to, ay 0.0821 liter atmosphere per mole Kelvin. So yan yung value ng ating gas constant kapag ganito yung units. Okay? So I prefer na i-convert nyo muna yung inyong mga units or mga parameters into their respective units na recommended ko dito sa taas bago kayo mag-calculate using the ideal gas equation. Okay? So here we have an example. So for number 1, at 25 degrees Celsius, 1 mole of an ideal gas expands from 5 liters to 15 liters. Calculate the initial and final pressure of the gas. Okay? So for the first step, prepare nyo muna yung values. So yung pressure nyo dapat ATM, temperature is Kelvin, yung anyong amount ay dapat moles, and yung volume nyo ay dapat in liters. So para ma-convert natin yung degrees Celsius to Kelvin, mag-a-add lang tayo ng 273.15 dun sa ating temperature in Celsius. Okay? So yung 25 degrees Celsius plus 273.15 Kelvin is 298.15 Kelvin. So, na-convert na natin yung temperature. Yung ating volumes ay hindi na kailangan i-convert kasi liters na sila. Yung number of moles natin ay 1 mole. Okay? So, calculate the initial pressure using the ideal gas equation. So, ginagamit again yung ideal gas equation kapag kailangan lang nating ma-determine yung isang parameter given the other parameters. Okay? So, from PV nRT, set natin sa P is equal to nRT over V, makukuha natin si 4.896 atmospheres kapag sinubstitute natin yung number of moles, yung gas constant, yung temperature in Kelvin, tsaka yung volume. Okay? So, the next thing to do is to calculate the final pressure using the Boyle's law. So, nagpalit tayo ng volume. So, nag-change yung volume from V1 to V2. So, kailangan nating malaman yung final pressure. Okay? So, kailangan nating malaman kung paano nag-change yung pressure. Gagamit na tayo ng empirical gas equation. So, ang ginamit ko ay Boyle's law. So, P1V1 is equal to P2V2. Set natin sa final pressure is equal to P1V1 over V2. Kapag sinubstitute nyo yung initial volume tsaka initial pressure over the final volume, makukuha nyo yung final pressure which is 1.632 atm. Okay? So for the next problem, calculate the temperature change when 0.5 moles of an ideal gas expands from 10 liters to 40 liters at 1 atmosphere constant pressure. So, for the first step, i-prepare lang natin ulit yung values. So, yung initial volume ay 10 liters, yung final volume ay 40 liters, yung number of moles of the gas is 0.5 moles, and yung pressure ay 1 atmosphere. Okay? So, for the next step, calculate the initial temperature using the ideal gas equation. So, from PV nRT, equate natin sa temperature. Temperature is PV over nR. So, yung temperature 1 or the initial temperature can be calculated kapag sinubstitute mo yung values. So, 1 atmosphere times 10 liters for the initial volume, 0.5 moles for the amount of the gas, and 0.0821 liter atmosphere per mole Kelvin for the gas constant. So, ang makukuha yung value kapag kasinod nyo yan ay 243.605 Kelvin. Okay? So, for the next step, calculate the final temperature using the Charles law. So, mag-work tong Charles law kapag constant yung ating pressure, which is given doon sa problem. Tsaka constant din naman yung number of moles niya kasi constant siya at 0.5 moles. Okay, so this will work. So T1 over V1 is equal to T2 over V2. Deriving T2, we have this one. T2 is equal to T1 V2 over V1. So substituting the values, we have 243.605 Kelvin. Okay, nakuha na natin yan. Tapos 40 liters yung ating final volume. Yung initial volume natin ay 10 liters. We will get 974.42 Kelvin. Okay? So, calculate the temperature change for the last step. Yung delta T is T2 minus T1. So, isusubtract natin yung value nito from the 974.42. So, 974.42 minus 243.605, we will get 730.815 Kelvin. Okay? So for the next problem, 1 mole of helium gas was placed in a 10-liter container at 25 degrees Celsius. So the container is then heated to 90 degrees. Then, the container is compressed to 5 liters while maintaining the temperature. So calculate the initial and final pressure of the gas. So assume that the gas is ideal. Okay? So first, tingnan muna natin yung mga given values. So initial volume is 10 liters, final volume is 5 liters. So yung initial temperature natin ay 25 degrees Celsius. Kapag kinonvert natin, magiging 298.15 kelvins. Kapag naman final temperature, 90 degrees na siya. Okay, given dito. I-convert natin sa Kelvin, 363.15 Kelvin. Yung ating number of moles is 1 mole. Okay, so given na lahat ng values, next step is to calculate the initial pressure using the ideal gas equation. So from PV equals nRT, we will get P is equal to nRT over V. So substituting the values, we have 1 mole for the gas, yung ating gas constant na 0.0821 liter atmosphere per mole Kelvin, 298.15 Kelvin for the initial temperature, tapos yung initial volume natin ay 10 liters. So makukuha natin ay 2.448 atmospheres. Okay? So for the next step, calculate the final pressure using the combined gas laws. So, for the combined gas laws, P1 V1 over N1 T1 is equal to P2 V2 N2 over N2 T2. Since equal lang naman yung number of moles sa initial and final state, hindi nagbago yung number of moles ng gas, we'll have this one. So, P1 V1 over T1 is equal to P2 V2 over T2. So, P2, okay, ito yung kailangan nating pressure, is equal to P1 V1 T2 over P1 V2. So, ito yung makukuha natin kapag dinerive natin yung equation. Okay? So, substituting the values for P2, we have 2.448 atmospheres for P1, 10 liters for the V1, yung ating 363.15 Kelvin for P2, 298.15 Kelvin for P1, and 5 liters for V2. So, we will get 5.69963 atmospheres for the final pressure. Okay? So now let's discuss Dalton's law of partial pressure. So this particular concept states that for a mixture of ideal gases, the total pressure is the sum of the individual pressures exerted by each component. So kung meron kang more than one component na gas dun sa inyong mixture, kung ano yung pressure na ine-exert niya, kung mag-isa lang siya dun sa system na yon, ay pareho lang din kapag may kasama na siyang ibang gas components. So regardless of the presence or absence of other components, pareho lang yung pressure na i-exert ng inyong ideal gas. Kaya kapag kukunin niyo yung total pressure ng system, you just have to add the individual pressures or the partial pressures of each component. So the total pressure is just equal to the individual pressures exerted by each component gas dun sa inyong system. Okay? So let's define another parameter. The mole fraction. Yung mole fraction, okay, is defined as the number of moles of a certain component gas 1 over the number of moles of all the gas combined or all the gas components combined. Okay? So, it's just the number of moles of a component gas or a certain component gas over the total number of moles kapag in-add mo na lahat ng number of moles ng lahat ng components. Okay? It is also equal to the partial pressure of gas 1 or as any gas component over the total pressure. Okay? So that's the mole fraction of gas 1 or any component gas. So para malaman niyo yung mole fraction, i-divide niyo lang kung ilang number of moles yung inyong component sa system over the total number of moles. Okay? Pwede rin in terms of pressure. So kung ano man yung pressure ng component na yon over the total pressure, yun yung kanyang mole fraction. Okay? So here we have an example. So 1 mole of helium was mixed with 2 moles of neon in a 50-liter container at 300 Kelvin. So calculate the individual pressures of neon and helium in the system. Calculate the total pressure and calculate the mole fractions of neon and helium. Okay? So para makalculate natin yung pressures ng helium and neon, we will have to use the ideal gas equation. So from PV is equal to nRT. Okay? Derive natin yung P. So that's P is equal to nRT over V. Since pare-pareho lang naman silang nasa isang container, that's a 50-liter container, yun yung kanilang mga volumes. So for the pressure of helium, we have the number of moles of helium, which is 1 mole, R, gas constant, temperature is 300 Kelvin, volume is 50 liters. Okay? So substituting the values there, we will get 0.4926 atmospheres for the pressure of helium. So sa pressure of neon naman, number of moles of neon is 2 moles. Okay? Same gas constant, same temperature, and same volume. So kapag sinubstitute natin yung mga values, we will get 0.9852 atmospheres. So the total pressure is the sum of 0.4926 and 0.9852. Ang makukuha natin ay 1.4778 atmospheres. So kung meron na tayong partial pressures at meron na tayong total pressures, we can now calculate the individual mole fractions. So for the mole fraction of neon, we get the pressure of neon over the pressure total or the total pressure of the system. So that's 0.9852 atm over 1.4778 atmospheres. That's just equal to 0.667. So kapag mole fraction naman ng helium, we will get, or we should compute the pressure of helium over the total pressure. So that's 0.4926, okay, over 1.4778, that's 0.333. Okay, so kapag inad nyo yung 0.667 at 0.333, ang makukuha nyo ay 1. So, ang sum ng lahat ng mole fractions ng lahat ng components sa isang system ay laging 1. Okay? So, this is my discussion on gases, and the gas laws, and calculations on the parameters of ideal gases using the gas laws and ideal gas equation. So, sa susunod kong discussion, I'll introduce you to thermodynamics na and thermochemistry. Okay? So, see you next video.